Okay, let's start with passage 3. Now, just like with our other passages, we're going to read through kind of the intro stuff here and then jump straight into the questions, because in the science section, we're trying to save time and be efficient in how we look at things and not be too bogged down with information. So passage 3 here says, when a solid metal, M, such as iron, nickel, or zinc, is placed in an aqueous hydrochloric acid solution, a reaction that produces hydrogen gas occurs. Okay, so there's the metal plus hydrochloric acid is creating metal chloride and hydrogen gas. Awesome. 2 experiments were conducted to study the production of H2 in this reaction. The apparatus shown in the diagram below was used to collect the H2 gas produced in each trial. So here's our picture here. Now, one thing to note about these pictures is oftentimes they're to help you kind of understand what's happening. Sometimes they ask you questions about it. More often than not, it's good to kind of just look at it, and this part here is going to explain what's happening, so you have kind of a basic understanding. So this says, as H2 was produced in the stoppered flask, so look, stoppered flask, so you run the reaction down here. It exited the flask through the outlet tube and displaced the water that had been trapped in the inverted graduated cylinder. This displacement occurred because the H2 did not dissolve in the water. The volume of water displaced equaled the volume of the gas. So they basically pumped the gas through this tube up into this upside down graduated cylinder, and the gas would collect at the top and push the water out, and they're able to see how much gas there is. And it says, in the trial of each of the experiments, step 1 to 3 were performed. The apparatus was assembled, and 25 milliliters of a 4 moles per liter hydrochloric acid solution was poured into the empty flask. A selected mass of metal was added to the flask, and the stopper was quickly reinserted. When the hydrogen gas production ceased, the volume of water that was displaced from the graduated cylinder was recorded. The apparatus and its contents were kept at a selected temperature throughout steps 2 and 3. The atmospheric pressure was 758 millimeters mercury throughout all 3 steps. Okay, so that's just explaining to us how it runs. We'll take a look at the experiments and the actual data as we need them. Okay, let's jump to the questions. Consider the volume of gas collected in the trial in experiment 2 for nickel at 30 degrees Celsius. The same approximate volume of gas was collected in the trial in experiment 1 for what mass of nickel? So this first one, let's take a look at experiment 2. In each trial, 0.3 grams of iron, nickel, or zinc was tested at a selected temperature. So we want 30 degrees, and nickel is the square one. So 30 degrees Celsius, the nickel produces about 128 milliliters of gas, we'll say. And it wants us to compare how much it took to do that in experiment 1. Experiment 1 says in each trial, selected mass of iron, nickel, or zinc was tested at 30 degrees. So we have different masses down here. So we want to find the spot where 128 milliliters of nickel. Now again, nickel, they have the same key as the square one. So we just come across here and we see, hey, the nickel produced 128 milliliters of gas at about 0.3 grams. So we can come down here. That's going to be H for our answer. Question 15, how many temperatures were tested in experiment 1 and how many temperatures were tested in experiment 2? Okay, so this question is asking about the experiment setup rather than the data. So let's take a look here. In experiment 1, one of the variables we're testing here is mass and the volume of gas collected. You'll notice, which we read up here in the experiment, each trial is at 30 degrees. So they only tested one temperature in experiment 1. Experiment 2, what they're doing is they're testing different temperatures. So we can see here, even though down here they have listed a whole bunch of temperatures, they only actually collected data 1, 2, 3, 4, 5 different times. So there was 5 different temperatures tested, which would mean that our answer is B. 1 temperature in experiment 1 and 5 in experiment 2. 16. Which of the following statements describes a difference between experiments 1 and 2? In experiment 1, okay, so let's read through our options here. Again, this one's much more about the scientific process rather than the data we're collecting. But it says in experiment 1, only Fe, which is iron, was tested, which that is fake. We can see they've tested 3 metals in experiment 1 and in experiment 2, so it's not A. G says Fe, Ni, and Zn were tested, but in experiment 2, only Fe was tested. Well, we just saw that they tested all 3 metals in both. H, in experiment 1, the same mass value of each metal was tested, but in experiment 2, multiple masses of each metal were tested. And that's wrong. In experiment 1, this is when we're changing the mass, trying different mass, 0.2 grams, 0.4 grams, etc. So that one's not right, which just leaves J. Multiple mass values of each metal were tested in experiment 1, but in experiment 2, the same mass value of each metal was tested, which is indeed true. This experiment 2 tells us we did 0.30 grams of each metal. In experiment 1, we were changing, so that is just J right there. Okay, number 17 here. Which of the following variables remained constant throughout both experiments? Okay, now this one I can do just from looking at stuff. The mass of the metal we just said changes in experiment 1, right? They're changing the mass, so the mass isn't always the same. Now experiment 2 is testing the temperature, right? The temperature is changing in that one, so it's not temperature. The volume of gas collected changes with each experiment, so it's not that one. The one thing that is constant is the atmospheric pressure. Now, it did actually tell us that. I don't know if you remember this. The atmospheric pressure was whatever that is throughout all 3 steps. So that was something that was explicitly stated to be the same. Okay, let's come up to 18. If a temperature of 5 degrees Celsius had been tested in experiment 2, would the volume of gas collected for zinc more likely have been greater than 107 milliliters or less than 107 milliliters? Ooh, okay. So let's take a look. So experiment 2 is testing different temperatures. Here, I'll erase this so we can see things better. Okay, and 5 degrees Celsius is off the chart. Okay, and it's saying if we look at zinc, which is the triangle one here, at 10 degrees, it had about 107 milliliters. So the question is it going to be more or less than that at 5 degrees? Now, all 3 of these metals have a very direct path that as you increase the temperature, the amount of gas that's produced also increases. So it's then safe to assume that if you were to continue decreasing the temperature, you would decrease the amount of gas produced. So we can come down here. We're going to say that it is one of these that is less. And let's see, H says it will be less than 107 milliliters because for a given metal, the volume of gas, of collected gas, decreased as the temperature decreased. That is indeed what we just said. Now, if we look at J, it says it would be less because the volume of gas decreased as the temperature increased. That's backwards, so it's not J, it's just H. 19. Consider the balanced chemical equation in the passage. Based on this equation, if 10 moles of HCl are consumed, how many moles of H2 are produced? Okay, here's one of the rare science questions that uses outside data, outside information to help you answer the question. If we come up to this balanced chemical equation, it says, hey, I have 10 moles of hydrochloric acid, and I want to know how many moles of hydrogen gas, H2, can be produced. Now, in a balanced equation, we can see we have a ratio here that there's 2 HCl for every H2. Scientists are lazy. We don't write ones when there's only one of something. So it's creating 1 HCl there. or sorry, H2. So because we have that ratio, we can say there is 1 mole of H2 produced for every 2 moles of HCl. And we can just multiply this through, so we can do 10 times 1 is 10, and then divided by 2 will be 5 moles of H2 that will be produced. That's one. Take chemistry to learn more. But it just comes based off of the ratios. For every 2 HCl, you make 1 H2. So if I have 10 HCl's, I can run the reaction 5 times and create 5 moles of H2. All right, number 20 here. Suppose that the trial in experiment 1 with 0.25 grams of zinc is repeated, except that the inverted graduated cylinder is replaced by inverted test tubes, each completely filled with 60 milliliters of water. Based on figure 1, how many test tubes will be needed to collect all the gas? Okay, so they're just saying, hey, basically how much gas is there? Asking us in a weird roundabout way of saying how many test tubes do we need? So let's take a look at 0.25 grams of zinc in experiment 1. So 0.25 grams, zinc is our triangle one. So that's producing almost 195 milliliters of gas. Okay, so we'll come down here, say, okay, if each test tube can hold 60 milliliters, we will need 2 test tubes in order to be able to fully contain the 90 milliliters of gas produced. Okay, because 60 plus 60 would give us 120 milliliters of space, which that's perfect for what we need to contain the 90.